In this video, I'm going to walk through the solution to this example problem. We're looking at calcium carbonate, and this is pulling in a little bit of the tools we used to look at ionic bonding as well as covalent bonding. When I see calcium carbonate, I notice that I have a metal ion, and I also have a polyatomic ion. And our Lewis dot structure and our resonance structures is really going to apply to our polyatomic ion. So I'm going to use this ionic compound to figure out the charge of that polyatomic ion. So my calcium ion is in group 2, so it'll be calcium plus 2. To balance out that positive 2 charge, my carbonate ion must have a negative 2 charge associated with it. So I'm going to draw the resonance structures for this. Now this is going to introduce a few fun new tricks. One, we get to try to figure out 3 total structures for this, plus I get to use this negative 2. When I have an ion and it has a negative charge, I get to add 2 extra electrons because it has a negative 2 charge. Anywhere I want in my structure, anywhere they're needed. If I had a +1 charge, then instead I would remove 1 electron from my structure. So let's set this up and come up with our first one and then try to build our resonance structures from there. So I have 1 carbon with 4 electrons, and it'll need 4 bonds. I've got 3 oxygen, each with 6 valence electrons. They're each going to need 2 bonds. And I've got 2 extra electrons. So because it needs the most bonds, I start with carbon in the middle. And the only other atoms I have are oxygen, so I'll place them around the carbon. I know that I'm probably going to need multiple bonds just because I'm noticing that I have very few atoms here. And that's why I'm choosing to put my atoms all around the carbon rather than linked up in a line. So I'll place these, making sure I'm matching up my unpaired electrons with an unpaired electron on carbon. There we go. I've got 3 bonds, and I'm going to check out my unpaired electrons. I've got 1, 2, 3, and 4. So with 4 unpaired electrons, my instincts would be to form 2 multiple bonds or ring structures. But I'm also going to remember that I have 2 extra electrons. So those are going to be paired up with an unpaired electron to create a lone pair. So I'm going to start out by creating 1 multiple bond between an oxygen and a carbon. Just connect these 2 right here. So I'll have a double bond here. And then I'm going to take my 2 extra electrons and I'm going to match them up with the 2 remaining unpaired electrons. And I'm going to redraw this. So I've got 1 oxygen atom double bonded to my carbon, and it has 2 lone pairs. And then I have 2 oxygen atoms that have 3 lone pairs and just a single bond to my carbon. And that is my structure of carbonate, CO3, -2. Okay. So this has an overall -2 charge, which I can put outside of brackets. Now I need to create its resonance structures. I like using this double arrow to show that I have equivalent structures between the ones that I'm going to do. And my kind of first step with resonance structures is to redraw the molecule with just the single bonds and place everything in exactly the same place. So that's a carbon with 3 oxygens, and I'm just going to place these single bonds and stop there. I need to preserve the arrangement of the atoms relative to each other, how they're actually connected. So I can't break any single bonds or add any new single bonds. This is my base structure I have to work with. And if I'm going to then move on from here, I'm going to be placing my multiple bonds and my lone pairs in a different way to form that resonance structure. So rather than have my double bond, sorry, there we go. I'm going to move it. I'm going to move it here to start with. So I'm going to put my double bond here. Any oxygen that has that double bond can only have 2 lone pairs and still satisfy its octet rule. And that's the trick with resonance structures. We still need all of these atoms to satisfy the octet rule. This means that my oxygens with single bonds will have the 3 lone pairs on them. So it's kind of like my lone pair and my double bond switched. And this gives me a second resonance structure. And I could do this one more time. I can now switch this double bond over to the last remaining oxygen. Remember, these are all different oxygen atoms. So I start by putting my single bonds, and I say, all right, it's this oxygen in the lower right-hand corner's turn to have the double bond and just 2 lone pairs. That means the remaining ones get 3 lone pairs, and I maintain that -2 charge. All right, I've got 3 resonance structures. If I wanted to make a hybrid structure of these, I'd try to take the average of them. And so again, I would redraw this with my single bond base structure. And then I would come in and I would put in some dots to show that these are partial bonds. And each of these is really going to be 1 1/3 bond, because that 1 extra bond right here is being shared over 3 carbon-oxygen bonds. And my extra lone pair that could be on any of my oxygen atoms, I can just kind of throw it somewhere in the middle because it's confusing about where that's actually going to be in the hybrid structure. And each of these will have a minimum of 2 lone pairs. And so this would be my hybrid structure, whereas these other ones would be my resonance structures.